I'm Tom Robinson. I'm talking about parsers and compilers today. So originally it was just called compilers, but it's actually more about parsers in general, and as they relate to JavaScript. So previously I started a company called 280 North, where we built a language called Objective-J. That was a superset of JavaScript, and it was implemented in JavaScript. So you would just reload your web page, it would load your code, compile it, and evaluate it. Not working there anymore, but Cappuccino is the project that uses Objective-J, and it's open source. It's a sort of desktop-like framework for building applications on the web. So I'm going to talk about two kinds of compilers today. Compilers that produce and consume JavaScript, and compilers that are implemented in JavaScript. And Objective-J is a good example of one that produces JavaScript, and it's also implemented in JavaScript. So they're not mutually exclusive. So before I started working on Objective-J and Cappuccino, I really thought of compilers as magic, really. Like, had no idea how they worked. But once you really start looking into it, it's nothing magic. It's code, and I hope that if you think of compilers as magic, you'll no longer think of them that way, and start experimenting with them, because there's a lot of cool things you can do. A lot of people think of compilers as something that C programmers have to use, and it's really not the case. There are a lot of other uses for them. There's a lot of good tools available for JavaScript developers and web developers, and you probably already use a lot of them. I'll talk about a few of them. So to start off, this is just a really simple example of a compiler for sort of a calculator. It's like a prefix notation calculator, kind of a little bit like Lisp. But I was able to fit each of the components into a tweet. So each of these is 140 characters or less. We've got a lexer that, I'll talk about each of these in a moment, but lexer, a parser, an interpreter, and a compiler. So let me just show a real quick demo of that. So just have a little program with a little REPL. I'm just going to copy this string here, but so if you're not familiar with this notation, it's just the operator is first. So this is 1 plus 2 plus this expression here, plus this expression and that expression, and then this is pi times 42, and this is 3 minus 4, and 5 divided by 6. So, whoops, that wasn't. So here, it's outputting each sort of stage that I mentioned earlier. The first stage is the tokenizer. It basically splits the input into tokens. You've got like a parentheses, a plus, a number, etc. So that's the very first step. The second step is parsing. Turns that stream of tokens into a hierarchical data structure called an abstract syntax tree. So here you can see, we have plus, 1, 2, and then we have another array here for that sub-expression, and so on. So it's pretty simple structure. It's just arrays, and then the next two steps are a compiler and an interpreter, and those are two different ways of evaluating this code. So both the compiler and the interpreter take the abstract syntax tree as an input to their code. So here you can see we lex the code, we parse it, and then interpret it, and outputs this number. And in this case, we lex it, parse it, compile it, and then just evaluate it. Oh, and up here, I skipped this step, but this is the compiled code, so it just compiled it to JavaScript. Changing it from prefix notation to JavaScript's infix notation. So here's that same process of laid out, starting with a string, going through the tokenizer, then the parser, and then either a code generator or interpreter. This is just the code for each of these functions, sort of unminified, ungulfed, I guess. And you can see here we're just using a regular expression, which is fairly common for tokenizing in parsers. And then we convert the numbers into actual numbers. The parser is this is sort of just a recursive function that looks at each token and decides if it needs to, add the sub-expression as another element, or if it's a literal that it can add. So that outputs the AST. And then this is just a very simple interpreter. It gets the function as the first node, or first element of the current node, and the arguments are the rest. And it applies those arguments to that function. Or if it's a number, then it just returns the number. And this last part here is basically looking up the function implementation in an environment, which just contains sort of the built-in functions for this interpreter. And here's the code generator. Basically just outputs a string with the operator in between each value of the node. So yeah, this is, I think, pretty relevant. A lot of people think of compilers as just desktop software, sort of Java kind of thing, but they're really useful for all kinds of things. So here's a few different things. So optimizers, minifiers, more advanced tools like Closure Compiler. Do more aggressive optimizations like inlining and unused code removal, that kind of thing. Linters will tell you sort of common errors that in your syntax. We can have alternative languages like Objective-J, or language extensions, also like Objective-J. Concurrency and security are two other applications of compilers I'll talk about in a moment. So yeah, Closure Compiler. Uglify is another fairly advanced optimizer. In parentheses, it shows you what language it's actually implemented in. So Closure Compiler is Java, Uglify is JavaScript and Common Lisp. Shrink-safe and UE compressor, I think, use basically the same parser. And then there's a couple others, less popular ones. Linters, there's JSLint, that's the popular one by Crockford. JSHint is a port, or a fork of JSLint with some different rules. JavaScript lint, Closure actually has a linter, and you can get linters for lots of different things: CSS, HTML. There's even jQuery. Not really sure what that does, but. So alternative languages, CoffeeScript is probably the one most people are familiar with. JavaScript's great. We all love JavaScript, but it has its problems, and some people prefer other languages. There's a lot of different options out there. Like pretty much any popular programming language has been implemented in JavaScript at least once, like sometimes several times. Here's just a few of them. So extensions to the language are an interesting example. So Tracer and Narcissus. So Tracer is from Google. Narcissus is the JavaScript. It's actually both an interpreter and just a parser. It's implemented by Brendan. And both of these are being used to sort of prototype new language features so that you can try them out in current browsers and provide backwards compatibility for older browsers that don't implement language features natively. So, and then Objective-J. So Objective-J, the first version of Objective-J was a custom parser, just hand-rolled. We really did that for performance reasons. So initially we wanted users to be able to just load up their application and have the JavaScript or the Objective-J compile to JavaScript on the fly without really noticing any slowdown or anything. But it became clear that even with very fast parser, it's not a negligible amount of time. So we've sort of moved to deploying with precompiled Objective-J to JavaScript. So it's less important now that speed. And I'll talk a little bit about language.js, which is a new parser generator that we've been working on for building the new Objective-J compiler. Here are a few of the things that Tracer in particular implements, the new language features. If you saw Brendan's talk yesterday, a lot of these things are proposed in ES6. So you won't need to wait until every browser implements these to start using them if you were to use something like Tracer to add sort of compatibility layer for older browsers. I'm not going to go through each one, but there's a lot of them. Concurrency is an interesting application of compilers. So if you're at all familiar with Node or any sort of asynchronous callback-oriented programming, you're probably familiar with the problem of all these callbacks scattered all over the place and nested and everything. So there's a lot of solutions out there that will actually let you write your code as if it were synchronous, and it will transform it so that it uses those callbacks internally, but you don't actually have to deal with all the callbacks. There's a few different projects out there. They all work a little bit differently, but security is the last sort of application I'll talk about. So there's this common problem where you have a widget that you want to embed in your web page, but you don't want that widget to access all of your data, steal your cookies or your private data. So there's these tools that will verify that the JavaScript provided by the widget is safe to execute, or it will actually transform it to something that's safe. And there's usually a pretty big performance penalty by doing this, because you have to sort of intercept pretty much every property access and that sort of thing. So ES5 I think is sort of strict mode in ES5 is sort of designed to make it a little bit easier for these kind of tools to work. So there's a huge list of all these different types of compilers at altjs.org. This is sort of a new little movement of people interested in alternative compilers and languages on top of JavaScript. So I encourage you to check that out. It's like a huge list, like hundreds of, I don't know if hundreds, but maybe 100 different projects. So yeah, those are the existing things that are already out there. But there's things that other people haven't even imagined yet that you could build. And so there's a lot of different tools out there. There's existing parsers. Narcissus, I mentioned earlier, it's written by Brendan. Tracer, that's the Google one, also implemented in JavaScript. Rhino has a parser you can programmatically access from Java. JSParse and JSParse.js, which are used in Uglify and a few different projects, and the JSLint parser. I'm sure I'm missing some, but these are a few of them. And if you don't want to use one of those, or if you want to build a language that's not JavaScript, or a parser for a language that's not JavaScript, you can use a Parser Generator, which basically takes in a language definition in the form of a grammar that defines how the language is structured, basically. And you input this language into the Parser Generator, and it outputs a parser either in JavaScript or one of many languages. It's typically easier than hand rolling your own parser. Sometimes it's slower, so that's one trade-off, or larger. A lot of times the code that it generates is very large, which can be a problem if you're trying to execute client-side. here are sort of the main popular ones. JSON. The second column is the language that the parser generator itself is implemented in. All of these parser generators, it will output JavaScript parsers. But sometimes you need to use Java, or I guess there's just Antler, which is a Java program that outputs a JavaScript parser. Then this notes column just mentions a few sort of what type of parser generator it is. So there's sort of two main different types of parsers. There's context-free grammars, which is what the LALR ones and LL ones are. And then there's PEG, which is sort of a different type of parser. The main difference between the two is CFGs, the context-free grammars, can actually have sort of ambiguous, the definition of the grammar is ambiguous, whereas PEGs sort of order the rules. They give each rule sort of priority, so it's impossible to have sort of an ambiguity in the language. All right, so here are a few other things that are possible with parsers. So you can instrument JavaScript, which is not commonly done, I don't think, but you can do interesting things like record stack traces more accurately than the browser will give you. So a lot of browsers won't give you good stack traces, but you can actually add a line of code at the beginning of each function to record the stack, and then pop that off at the end of the function, and you'll have an accurate stack trace at any point in your program. You can catch exceptions, cross-browser, completely the same in every browser. And there's this company called Proxino that's actually doing that. They give you a proxy that you load your JavaScript through, and they automatically do this for you and report back errors and give you like a nice dashboard and stuff. It's pretty cool. You can do things like code coverage. I saw this project called Heatwave that I think was done at one of the Node knockout things or something. It's pretty cool. It sort of gives you a heat map of your code, like as it's executing. And it does that by, again, putting a function call at each line of code and recording when that line is executed. You could do things like runtime type checking. If you were to declare all of your types in some sort of readable format, either in like a comment or something, you could read that in and generate code that actually checks that those arguments are the correct type. And debugging, which is the last thing I'm talking about. And so I sort of started working on a code coverage tool a while ago, and was instrumenting my code to record which lines were called. And you can get like sort of a report of your test coverage, basically. Show like what percentage of each file is covered by your tests, and that was cool. But I realized if you could actually block the execution in each of these statements, you could sort of do a debugger kind of thing where you step through each line, that kind of thing. So I created this project called Zbug. It's basically an instrumenting JavaScript debugger that's written in JavaScript. So it's entirely JavaScript. It works in any JavaScript interpreter. The one thing it does need is a synchronous API to block execution. So in the browser, that basically means either prompt or a synchronous HTTP request. And we all know those are evil, but for this purpose, it works pretty well, actually. So, and it works everywhere. So, like, you could run this, in Rhino, or Photoshop has a JavaScript interpreter. You could use it there, pretty much anywhere. And so it implements the V8 debugger API. So rather than building my own UI, you can actually just integrate with any of the debuggers that support that V8 API. And there's quite a few, actually. So the Webkit Inspector is one. Eclipse has one. I think there's a few others. Cloud9, I think. So I'm going to show that to you real quick. How am I doing on time? So if you have a computer, you can play along. Oops. Okay, so if you go to this IP address, there we go, someone just popped up. Someone else, it's just showing me your IP address and your user agent. So I can actually, go to one of these. Whoops, oh yeah, so it turns red when somebody is connected, so. Oh, is that not working? Okay, well, let me try it myself. Okay, so it's working for me at least. This is, the code that's running on here. It's just printing out a bunch of stuff like every few seconds. So I could actually add a breakpoint in here anywhere. And next time it times out, it should open up, it should break, maybe not. Okay, oop, that's not good. I'm gonna disconnect you guys because that's probably not working well. Okay, let's try this again. Okay, so the perils of live demos. I don't think that was me. Okay, try one more time. Okay, there it goes. So you can see it's selected that line, and if I go over to Safari, it's completely unresponsive. So that's one problem with this is it actually does completely lock up your browser. So if you're using Chrome, that's fine because each window has a different process, and it's not going to block your debugger process. But if you were to try to debug Safari in Safari, it'll just sort of block up the entire UI, and you won't be able to do anything. So I can actually, step through. The line numbers on this are off a little bit right now, but you can kind of see it. Basically stepping through all these. You can disable, enable breakpoints, evaluate code. So I should be able to actually get that string. Yeah. So you can, evaluate in the actual context of the function that the breakpoint is on. That kind of thing. So it's still a work in progress. It's a little bit buggy, and there's still some stuff that's not implemented, but it's getting there. And I'm going to release this. There's a really old version on my GitHub right now, but that uses prompt statements to do the blocking, so it doesn't have the nice interface. So I'll be releasing this in a few weeks, hopefully. So that's pretty much it. I'll take questions, I think, if I have time. I don't know. How am I doing on time? Okay. Any questions?
Knowing what you know now and how things have shaken out in JavaScript for the past 2 years or 3 years since you guys started with J.
Yeah.
Is there anything you learned or would have done differently?
I probably wouldn't have created my own language, but I mean, it's just a lot to ask of people to adopt an entire language and a framework, and it was great for the people who were interested in the Cocoa-like environment that Objective-J and Cappuccino offers, but and there's a lot of people using it for great stuff. It's just it's hard. It's a lot to ask of people, and but I'm a big fan of the things like Tracer and the Narcissist stuff, where they're adding these new language features that are sort of driven by ECMA and those kinds of things, and we'll be able to use them a lot sooner than if we had to wait for every single browser to implement them and every single user to start adopting them. So, yeah. But I still encourage you to build your own languages and play with it at least. And things like CoffeeScript are great. So, it's not it works great with existing JavaScript libraries. So.
Have you worked with the generators? You mentioned the generators.
Yeah, I haven't done a lot of stuff with the generators, but
My question would be, have you found a good grammar for JavaScript along with the generator?
So I think there's one for JSON. I think one of these, let's see which one. Tame.js uses a JavaScript grammar. I haven't really evaluated it, but there's definitely one for that, and there's one for language.js, which we use as the foundation of the Objective-J one. Since Objective-J is a superset of JavaScript, we basically just add a few new rules to the JavaScript one. And there's one for Antler. I tried to get that to work once, never got that working, but yeah.
So you mentioned that you think that you can't do the live parsing because it's too slow?
Yeah.
But what would you call too slow?
At one point it was taking like 45 seconds, but we were compiling the entire framework, which is fairly large. It's like a megabyte of JavaScript. So.
Alright, so there are parsers that can do that, but these can probe in like megabytes, say, 700 milliseconds? Would that be acceptable?
Sorry, how much?
700 milliseconds?
Oh, yeah.
7 seconds?
Yeah.
Would that be acceptable for you, or?
Sorry, what?
Never mind, I'll do that.
Yeah, I mean, it depends on your type of application. Like for Google.com, no, but you're not going to need that much JavaScript for Google.com. But if it's like, our flagship application that we built with Cappuccino is 280 slides, and it loads in 3 seconds, something like that, which is faster than like PowerPoint opens on your desktop. So I think that's, for those types of applications, it's perfectly acceptable. So. And you could do interesting things like, if the user has already loaded the page once, you could actually cache the results of the compilation in local storage or something like that. It could be interesting.
Can you actually use your debugger experiment to play with new languages to debug them and represent source in the original language itself?
Oh yeah, I haven't done that yet, but yeah, you can definitely use this as a sort of native debugger for other languages. Basically, instead of sending it the raw compiled JavaScript code, you would send it the original source code for your language, like CoffeeScript or Objective-J or whatever, and there's this new proposal for a mapping of, I think you map the original source code to the compiled source code lines, so the debugger can actually show the correct code, and this could certainly support that.
Web Inspector, I can say, is it actually served from the Web Inspector that touches Chrome, or it's from the server?
Oh yeah, no, I forgot to mention. So this is using Node Inspector, which is, Web Inspector for Node. Basically, I mean, it actually would work for anything that supports the V8 JSON API, V8 debugger API. So you could also use the Eclipse debugger, whatever. Cool. All right. Thanks.